Everything in here is on rollers so that I can move everything around because I have such, believe it or not, limited space. I'm really good at filling up space with stuff.
I think that's a human thing, isn't it? Like, you give us more space and we fill it up. Welcome back to Christina's Garage Gearhead in Training. This is Carlos. I met him a couple weeks ago at the Metal Cloak NorCal Stampede, and he was telling me how he does a bunch of metal fabrication, leather work, like all of the things. And then he's actually making his own, what do you call it, the 4800?
Yeah, it'll be based on a 4800 class race car for Ultra4.
And so I'm out here in Wilton, and he's gonna tell me a little bit about it.
You start out with the subframe, which is this part down here, and then you build your way up. But there's like the Dragon machine out there. This will output to the Dragon machine, which is the CNC tubing cutter. It'll cut each individual part, and you can have them cut all at once, or you can cut individual parts once at a time. Or if you didn't have the Dragon machine, which is, I just got the Dragon machine not too long ago. If you didn't have the Dragon machine, you can go in here and look up a particular part. Say I wanted to cut this particular tube. You click on the part details for that tube. That'll give you the actual details of that part. It'll tell you how long to cut the part, where to locate the bend at, and what angle to bend the actual bend to. It'll also give you templates to make the copes for the joints on the end. So this is how I start. Now everything I start designing in this program is called BendTech. Basically the chassis that's out there that I'm building now with some differences. And that's just the tubing portion of it. It's not the axles or the bracketry or any of the other stuff.
Yeah, watching how you put the tire on is interesting. His tires and wheels are heavy.
Yeah, they're heavier than hell.
Especially these ones, the off-road ones.
Yep.
They're even more massive.
Yeah. Yeah, talk about hurt your back.
Yeah. Well, when I've done the wheels on my car, I'll sit and use my leg, but it's not so high and the wheels aren't as big.
Yep.
So you're getting it lower to the ground so you don't have to lift it.
Yeah, we'll see if that works.
Do you need a little bit higher?
Yeah, just...
Do you want me to push this under? Was it right here?
Yep. Make sure it's rotated to the right, the handle, and then just give it just a little jack. A little more. That works.
Voila. And just leave it there.
Yes, please.
I'm trying to learn the terms of all of these things. You have, is that the hat?
So, no, that's a brake term.
Okay.
So what you're looking at, the most outermost part is a unit bearing, and most modern cars use unit bearings now. And then inside of that is the knuckle.
Okay.
Then inside of that is the inner C.
So this is the knuckle.
Yeah, what the unit bearing bolts to.
Okay.
Inside of that is the inner C.
Which is the big metal piece that moves, this one?
Now this is the knuckle.
Okay.
This is the inner C.
Oh, because it's a, okay.
And then you have your actual axle housing. And then inside of all of that would be an axle shaft that runs out and supplies, transfers power to both tires, both wheels.
Because mine doesn't have this, what do you call this?
You have a third member, so in the middle where the differential is, it's called the third member. That's where your gears are. That's where your drive shaft sends power to the axle. So if you have a live axle, meaning live axle would be a drive axle. On your car, you only have a drive axle in the rear.
Yeah.
So you have a third member in the center, most likely, or maybe offset a little bit. And then you have your axles, the actual axle shaft that goes out through the axle housing. And then on the ends, you have a different type of axle. Yours is probably a semi-float axle.
I don't have anything like this on my Camaro.
You don't have the different suspension links and stuff. Is that what you're referring to?
This, I don't have another one of these in the front.
No, not on the front. You won't have that on the front.
I just have one in the back, and then I think it has like a hole for
your
one
drive
axle
shaft.
down. Yeah, the drive shaft, yes.
Yep.
And then all the rest of it's kind of empty right now.
So you have a live axle in the rear. It's just it's a different type.
Okay. So you have this because it's all-wheel drive or four-wheel drive, or?
Right. So you're going to have a drive axle in the front for four-wheel drive, and the drive axles on the front are always offset because the output from offset, meaning where the drive shaft connects, is always going to be to one side or the other, because the drive shaft has to go around the engine. Because
that makes a lot of sense.
Back here, this big silver thing is called a transfer case. And this transfers the power to both the rear and the front. So you have your transmission, transfer case powers or sends power to the rear and the front. On your car, you don't have a transfer case. This is only two-wheel drive. So you're coming straight out of the transmission to the axle.
That's cool. So my husband's, when I was telling you we changed the alternator, we took the axle out of one of the sides. So I think there is a transfer case or something in my brother or my husband's, because his is either it's all-wheel drive. I think it's all-wheel drive. His, so he has a transfer case and stuff.
A transfer case or transaxle of some kind.
Because we took out part of the axle in order to get to the alternator on my husband's. So it's interesting to see like how all the different cars, they have a lot of similarities and also differences as well.
Right. Yeah,
I don't even know what my truck has.
You have a transfer case. Is your truck four-wheel drive?
I have the option to do four high, four low.
Yeah, you're four-wheel drive. So you have a transfer case.
Okay.
Yeah. Except for you have independent front suspension. You don't have a solid axle front suspension.
Oh, okay.
So it's a little different. The front gear set, or the third member, if you think of the gear set as the third member is fixed in the chassis. And then you have two things called axle shafts with CV joints that move up and down with the suspension, because you have IFS, or independent front suspension.
Yeah.
And then the third member itself stays in place on the chassis.
Okay.
Whereas this is more of a live axle, so it's got a solid front axle, and the third member moves with the.
And because that's a requirement for the 4800 is to have, you're not allowed to have the independent
Right.
rear or front suspension for that.
Correct. Yeah. And there's debate on whether or not in these type of cars, whether or not solid axle or IFS is better for some of the more gnarly rock trails.
Oh, interesting.
So like when you go to King of the Hammers, that's the big debate, whether the solid axle or the IFS is better.
Because IFS would be better for rock crawling, right? The slow.
No, IFS is better for desert, for go fast desert.
Oh, okay.
Yeah.
Interesting. Because I know that independent rear suspension for autocross, at least, because when I went to Speed Tech Performance, they do the independent rear suspension for the autocross stuff because of all the maneuvering, the turns and stuff when they do really quickly and everything, to have that ability so that the wheels stay on the ground.
Yeah, that's the main thing in road race. I don't know a whole lot about road racing, barely anything at all, but the main thing is keeping your tires planted on the ground so you can take advantage of traction and drive in all scenarios on all four tires.
And for you guys, though, you have a lot more suspension, too, so you're finding the in-between, because the suspension is making up for the fact that this is what do you call it?
Solid.
Solid,
Yeah.
because the suspension allows the wheels to do what
Yep.
it needs to do. It's
Yep.
just mind-boggling.
And
to me.
there's a big debate over whether or not, and it's not so much anymore. I think IFS has pretty much proven itself, especially in the unlimited class at King of the Hammers, because IFS has won more often than not in the last 5 years. But there still are really well-known and viable solid axle cars that have won too.
Wow.
In the unlimited class. So there's so many. That's what's so cool about this is there's so many different ways to skin a cat, and it's up to every individual's idea of what they think is best. So when you go to unlimited class, it's like run what you brung. If you go into the 4800 class and some of the lower classes, there are rules. Like with this, obviously you got to have a solid axle front. 4800 class, you have to have DOT or streetable 37-inch max tires.
Oh, so you can't go bigger.
No, these tires right here, I could not run. I wouldn't be able to race with these tires because these are race tires. They're 40-inch sticky tires. I don't know that I'm going to race this, so that's why.
So you're building it with you could do the option to put the tires on for racing,
right.
And then also, as you were talking about, when you turn the tire, you put the tires on with the metal fabrication part.
Yeah.
To make sure that when you're turning, you're not rubbing on anything, that you have the right, clearance?
Clearance throughout the entire suspension travel. So like, we'll just say this car, I think it's set up for 19-inch of vertical wheel travel, straight up and down. So the tires got to clear everything, the shock, the frame, the links, in all different positions in articulation between that, say, 0 to 19-inch. Turn right or left or going straight. And that's why like this step of the process of building the buggy is so important. You've got to test all that stuff out before you start welding everything in permanently and make sure it's all going to work with all the different componentry you have. So like right now where I'm at in the build process, if we were just to focus on the front end, is I've got my links on the front axle, which would be in other circles would be called control arms. We call them suspension links. This is a 4-link front suspension. I've got them pretty well solidified in place on the front axle. I've got that all welded in. I've got my shock position kind of figured out. It's still not completely solid up here. I still have the ability to move it back and forth. These are just temporary brackets. But the lower mount on the shock is set in stone on the axle. And what I'll do is articulate the front axle and make sure that it's going to clear the shocks, which I've already done all of this, but I'm going to double check again since I've welded all this in, make sure the tires clear the shocks in all positions. Then from there, I've got to put in a front drive shaft and make sure the drive shaft is happy throughout the complete suspension cycle, because your drive shaft has limitations. The U-joints in the drive shaft can only go to a maximum angle before they bind. So you have to remember on Trent's car at the race, I was showing you the big strap that looks like a seatbelt.
Yeah.
So you have to size that seatbelt in some cases, not only so it doesn't blow the bottom of the shocks out when that whole front axle droops out, you also have to size that seatbelt to where it limits the downward travel to keep the drive shaft happy.
Oh, because you don't want anything to buckle
Bind.
and break and...
Yeah, once they start binding, it's over with. It's all she wrote. So the U-joints are, depending on what size they are, they have a limited amount of angle they can operate at before they bind. And when they start binding, they break. So there's all kinds of things, all kinds of different elements to think about. And that's what's really cool about this, is because for me, it's a big puzzle and it's a challenge. And some days are better than others, but when things go right and everything you've premeditated, like I said, you think 5 steps ahead. When all that sort of comes into place, it's awesome, because for me, it's a big sense of accomplishment, and that's what drives me, is just building and creating, building and creating. I'm not happy unless I'm creating.
And you said this is your 4th build?
This is my 4th chassis.
Okay.
This will be my 2nd complete build out as far as a running and driving off-road car.
The other chassis that you've done, did you use the same like measurements and all that stuff, or did you change?
Varied slightly. Each one I've tried to improve a little more. And like, you know, like I said, this is kind of a side hustle. It's a side hobby, I guess, if you will. It's not a main business. I'm not making money off of it. It's just sort of I guess you'd call it a passion, something I like to do. And I'm learning every day. I'm no expert. It's just what I've seen works, what I've read works, and then kind of formulate that and kind of turn it into my own program. And like with this chassis, there were things that I wanted to do differently over the last chassis I built. Like I learned that I needed a wider track width on the front end to make the particular shocks that I want to run work. I learned I needed to narrow up these front main frame rails so it would clear everything. I learned I wanted the engine a little bit further set back, so my center of gravity's further back in the middle of the car. There's all kinds of little things. We could go on forever talking about it. Like, you can just keep on rolling and you can cut this thing up into all kinds of different videos because there's so many different little things. A 16-inch shock is only going to do so much. Collapse length on a 16-inch shock is a set number. Let's say it's 27.5. Fully extended length is, I don't even remember. Let's say it's whatever 27.5 plus 16 is, right? So we know that the shocks are only going to do so much, but then you get into the type of shock. Is the shock going to be a 2-inch body, a 2.5-inch body, a 3-inch body? On these shocks, these are 3-inch body shocks. So the body itself is 3-inch. But when you put the spring on it, that grows to a 5.25-inch or 5.5-inch outside diameter by the time you put the spring on it. So those ones over there are 2-inch, and they're a fraction of the size of a 3-inch by the time you package it with the spring. So that's where that frame rail needs to come in, because if let's say you have your shock here, right? And that tire is all the way up in its travel, but this tire goes all the way down in its travel. It's going to swing the shock, or vice versa, into the frame rail. So you've got to make sure you're placing the shock to where it's happy throughout the entire suspension travel. And because of the fact that it's got so much vertical wheel travel, the angle of the placement of the shock changes so much with the suspension travel that, you know, everything here has got to work in conjunction. That's where you're thinking 5 steps ahead.
So you're moving this as you're building it, you're shifting the whole thing and making sure that it's not just hypothetical, you're actually doing the movements.
That's right, and that's where like the lift comes in handy, or a forklift. You know, if this thing was a little bit more further along, if things were a little bit more solid welded, I could use the forklift to do the same thing. I could flex out, I could stuff one tire, which would in turn take the opposite tire in the other corner and completely extend it out. So you could test your suspension travel that way.
That's cool.
There's all kinds of things. I was going to upgrade the axles in that buggy because originally it started out with all Toyota stuff. And I thought there was plans out there on a couple of the websites. You can download plans. The majority of everything I've designed myself, but here and there you can download some stuff to just like Etsy, you know, you can download designs. Well, there's a website where you can download off-road stuff, and they had designs for designing or for cutting out and fabricating your own axle housings.
Huh.
So I thought, well, I'm going to do that. I don't know, a couple of years down the road, after I designed and cut out and welded out the center sections, I built out the complete rear axle, which is that one sitting there in the rack. I didn't realize when I started welding it up, there's a truss on the back of it, kind of like this, but it runs along the back side of the axle for strength. As I was welding it up, it just started to bow.
Interesting.
And no matter what I tried, I couldn't get it to straighten out. So the axle housing in the back is a very common manufactured axle housing by spider tracks. That's very common in these desert cars and off-road Ultra4 cars. But the front axle is still my own complete home-built axle. And the outers here, the knuckles, the C's, these are made by spider tracks, but I bought them used. So I repurposed them, I cleaned them all up and welded all this stuff on here. The upper, these are called high steer arms.
Yeah, what are all these for?
So the original design had bolt-on high steer arms. And they would bolt on right here. They're over here, actually.
Oh, so the bolts are there to hold something else that attaches.
Yeah, this is originally what they were built for. These. So these would bolt in right here. But I decided not to go with these because I wanted the steering attachment points to be higher, and I wanted them to be in double shear.
So you're gonna fabricate your own?
So this is all a kit that I bought from Miller Motorsports and welded it all together. So normally what you would do is just attach your steering link right here. But not only did I want them higher, so that 3 steps ahead, where there's a steering ram that goes right here, a hydraulic ram, I wanted it up higher. Because if I would have went with this, it would have made the ram right here. Well, you've seen those cars blasting through the rock piles.
You're more likely
Guess what
to
it would have
smack
hit?
it.
Yeah. It's my belief that anytime you use a Heim joint, which is what these are, this is a Heim joint, they should be in double shear. Should be mounted in double shear.
And double shear again is?
Basically, it's a plate above and below the Heim.
Okay.
Because if you only have, in most cases, and I've experienced this with the rock crawler, if you've only got it mounted in single shear, because the pillow ball and this pivots, that bolt ends up backing out. The mount bolt.
I feel like I have to see a single shear to, because I think I understand what you're saying.
So in the middle of the Heim joint, you have this pivot ball, and that's made to pivot around. You'll have like what's called a misalignment spacer, which goes in here and gives it more pivot or articulation. So like with the suspension links, it needs to be able to clear in different positions on the axle. It needs to be able to pivot around like that. If you only have this mounted, here's another Heim joint. It's just a smaller one. This is 1 1/4 inches, and I think this is a 7/8 or 3/4. If you only have a Heim joint mounted, and that doesn't even fit, but if you only have it mounted in single shear, say your bolt's going through there, and this pivots, what happens is eventually the bolt and the nut will loosen up because it's pivoting so much, and the vibration ends up allowing it to loosen up. So what I like to do is mount it in double shear. So if you come over here to this side, you'll see that instead of having the bolt run through a single plate like on this, you have it running through this plate and this plate on the bottom. And that keeps that bolt from rocking and loosening up.
Oh, okay.
So that's what's called double shear. That's referred to as a double shear mount for a Heim joint. So the original steering arms that came with these spider tracks knuckles, I didn't want to run because number one, they're too low on the axle center line, and number two, they weren't double shear.
That makes a lot of sense.
I'm really big on mock-up stuff. So like that transfer case, especially right after COVID, there was like an 8-month wait to get a transfer case from that manufacturer.
Oh, wow.
And that manufacturer for off-road, that manufacturer pretty much has the corner on the market. It's made by Advanced Adapters, or they call it an Atlas transfer case. So what I decided to do was just like the engine is a mock-up engine. It's all made out of sheet metal. I decided to make a mock-up transfer case kit. And that's what's kept the Tack One Fab website going, because I sell a bunch of those mock-up transfer case kits. Well, it's basically set up to be a placeholder. So when you're Because really what you're doing, most cars, especially if you're building custom chassis, whether it's a race car or even maybe it's a street car or something, if it's a custom chassis, you're designing your chassis around the drivetrain. And when you don't have all the elements, like I said, during COVID, these transfer cases were like 8 months out. If you don't have a transfer case to build around, then you're dead in the water. You can't keep continuing with your fabrication. So I just, out of necessity, designed this sheet metal transfer case, mock-up transfer case, to take the place of the real deal so that you could keep on building as a fabricator. And there was nothing out there that you could, there used to be somebody that made them, and they stopped making them for some reason. And there was another guy that was 3D printing them. And if you know about the 3D printing process, they were very expensive to buy. Because if you know anything about the 3D printing process, it takes forever to print an item that big.
I didn't even put 2 and 2 together that this isn't, it looked so real. I didn't even like double look at it. That's crazy.
That is made and sold by Speedway Motors.
So you essentially, same idea, just for a different part.
It has, yeah, so it's a mock-up engine. It's got all the same mounting points, same dimensions, same everything. So I'm able to mount up a real oil pan, a real set of headers, exhaust headers. I'm able to bolt up a genuine transmission to it in the same exact location that a normal LS engine block would be. But the thing, the thing is after I unbolt all this stuff, I can grab it with one hand and take it out.
A regular engine would be way, way heavy.
It's a hell of a pain in the ass to move the big engine around, yeah. Right there. Spare tire sits up way, 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 way high.
Oh yeah, and how it got knocked off because Chucky got
yeah,
got a little bit of bumper cars going on.
So this, and this is not, I'm not the first guy to do this. There's a lot of other designs, but this back part right here, let's see if I can do this without blowing a Hemi.
I've seen some that have it low like that too.
Yeah, so that's what that back part's for.
And that helps with weight distribution too, right?
Exactly, lower center of gravity.
Because I think they were talking about, because it had broken, that luckily they had the straps to keep it in place. They said you don't need the tire on there for function, it's the weight distribution as to why you want it there.
That's exactly right, because the shocks are tuned in such a way to handle the weight of the tire and a full tank of fuel. And when you upset that balance, if the car is tuned in that particular way, when you upset that balance by, say, taking the tire off, then it won't drive, it doesn't perform the same. So even though he didn't need the spare tire and wheel for the race, he still needed it for the shock tuning because the car was set up to handle that weight, and it's gonna perform a little bit differently, especially in the corners and things like that. You'll see, like in a lot of areas, things are only just tacked together. There's little tack welds.
Oh, so okay,
So
I didn't know.
It's not fully welded because I'm still in the mock-up, we call it mock-up phase of the build. There's areas on the chassis that are fully welded, like down there, those ladder bars that are coming out, or the outriggers, kind of by your knee.
Oh, these ones?
Those are fully welded just because I know they're not going anywhere. That's part of the design.
This is tack weld,
this is
tack. So like when they're just like a weld just to hold it in place.
Yeah, it just makes it super easy to take apart if I find that something's not clearancing correctly or whatever.
Like this looks like a full
yeah, that's
weld.
going to be there. That's going to stay there.
This. Ah.
The next thing will be, I got to figure out the location of this carrier bearing, because the front drive shaft is a 2-piece drive shaft.
Oh, I noticed that there was a piece.
Right. So that's the carrier bearing. So there'll be a short mid shaft here, and then the front drive shaft that goes up to the front axle. So I've got to make sure the location of that carrier bearing is forward enough to make that U-joint happy and out of the way enough to clear the transmission bell housing. And then I'm going to have to sneak in a exhaust flange of some kind in there and connect that. But that'll be the next thing. Is I've got my third members finally, which are, see that thing in the back where the drive shaft bolts into in the center of the, I told you what a third member is. That's where your gears are.
Right there. Okay.
So I finally got my actual third members, so I can put my third member in the front and start making sure that my drive shaft is going to be happy and locating that.
You can't tell without it being in place.
You can get a really rough idea, but you need the genuine article to be sure.
So you're going to have a fixed one here, and
Yep.
then two of those other ones. So one in the front.
The other ones will have slip yokes in them.
So one in the front. Oh, where's my finger? Somewhere over here to up there. And then a bigger one in the back between here and here.
So this is the mock-up front drive shaft. These are your U-joints.
It gives you more articulation of movement because you have multiple pieces that can go different directions.
Right. You have to have a U-joint because you have the suspension, and your suspension's not always in the same place at the same time. So
this is a different, so you have that going that way and this going this way.
right. And you have, so you've got two things going on with the drive shaft. You have your slip yoke and you have your U-joint. And the reason you have the U-joint is because the drive shaft is never going to remain at the same angle because your suspension is going up and down with the road. You have your slip yoke because the distance from mount point to mount point changes, so this slips in and out.
Because you have so much movement and travel.
Yeah, so in a regular streetcar you don't have that much movement, but this is probably seized. No, here, it's not.
So this one you said, this is the slip.
That's your slip yoke. The length of your drive shaft is going to change, and especially it changes quite a bit more on an off-road vehicle because you have so much vertical travel. But like on a streetcar, it changes just minute, maybe fractions of an inch because you don't have all the suspension travel that like an off-road car does. But you need to have a way for your drive shaft to extend and retract to go along with that suspension travel. And then you have the U-joints to change with the angle of where the front drive shaft, or the front of the drive shaft is connected to the axle or the third member. So like the original design, you can see it more so in that one, it was originally designed on the body lines of a Corvette Stingray. So that's why everything's rolled, has kind of that swoopy look to it.
I didn't even realize until you said that. It's so cool.
And so there's another chassis manufacturer that has sort of that same line to it. And every time driving that thing on the Rubicon or Ford Ice or any of the local trails, every time I'd stop, somebody I didn't know and visit whatever, they'd ask, well, is that a wide open design chassis? And I'm like, no, it's not. I built this. And so on this one, I wanted to do something a little different. So I put this little dip in the door bar instead of having it rolled. So.
Oh, so rolled is more like kind of like this, how it kind of goes like this?
Yeah, see how on this one the door bar is radiused?
Yeah, kind of goes down.
And this one just has a bend in it, it's not radiused.
Okay, so otherwise it would have come down a little bit more here
and then
versus here and then up. It just, I didn't even realize it initially. Now I can see it.
Yeah.
It's just like a tiny.
So, and then the back half is rolled, and then the front half is rolled.
Because it comes up and that's cool. You don't realize how much equipment and time and like online program, like all the things.
Yeah, and I mean, that's what I was going to show you. Before I was doing everything with this. I'll get a piece of tube and show you. But I was telling you about this machine, how it notches and copes stuff. Mm-hmm. Before I'd have to do all that with this.
Oh.
So to notch a tube, you'd have to hand drill You set your angle, you run your drill through with the hole saw and notch and cope. That machine does it in seconds, where this thing you have to sit there and figure out your angle and do a bunch of trial and error and make sure everything's set up right. You can get pretty good at it and pretty fast, but it's a hell of a lot more labor.
What do you use to bend everything?
The bender's over here.
Oh.
So this is the bender. And then like the tube goes in. Tube goes in here, you apply air. So this is an air over a hydraulic cylinder. And this will come up and bend the tube around this die.
Oh.
And there's an angle finder right here. And here, I'll turn this around so you can see it. There's an angle finder right here, and you stop it at whatever degree you want to stop that bend at. And they make machines that are a lot more elaborate than this, that are digitally controlled. And this one's pretty basic, but it's a very popular brand that a lot of guys use for this kind of work. And you have to get a different die set for each diameter of tubing that you're running or working with. Like, so this, I have a 2-inch die set and an 1 3/4 die set. This is all built out of 1 3/4 for the most part.
Oh, okay, that makes sense.
And then I have another bender over there that I've used as well, that I have some smaller dies for, but it's not as heavy duty as this. This one will bend like quarter wall thickness, 2-inch, really heavy duty stuff.
Thank you, Carlos, so much for having me. Like, as I just told you, I'm starting to hit my wall in terms of all the information. Still, like, it's all really cool, and I'm excited to like tailor the information to stuff that I'm gonna do, and then I would love to come back and learn some more.
Anytime.
You know,
I'll share everything I think I know, for sure. So.
Right, we all think we know all these different things, and we all come together and
always learning.
Yeah.
So anytime you want to come out, I'll put you to work.
Yeah, I'm looking forward to it, and if you guys want to follow what he's doing and maybe get what are the transfer case.
Mockup transfer case, yeah, it's at tack1fab.com.
And I'll put all the information in the caption, so if you guys want to look into that. And he also has leather work. I'll put all of his information in the caption, and I'll be back.
Yeah, for sure.
Thank you so much, you guys. See you next week.
Bye.